Hello, g'day there, everybody. Hey, my name's Stephen Pappen. I'm that little hairy guy with more knowledge than social skills. And today I wanted to put together a bit of a video. Like I said, sometimes my social skills aren't quite there, and I don't really think. I'm thinking more about the facts and details than about people's feelings, and things don't really come across correctly. And it can be difficult for some of my friends sometimes because I don't like to talk about stuff I don't know about, and I don't like to talk crap. And I don't really humor stupid ideas either. Like, I like people to look into things, to think about them, to apply themselves a little bit. And that's all well and good. But then I think some friends have tried to connect by seeing topics they thought were clever and then didn't really come across when I've responded with things like, no, going to Mars is a stupid idea. And then, yes, I well could have explained a little more than just saying a blanket statement, but no one wants to be lectured at and told for 10 minutes all the details of why there are other places that make more sense. So, for those friends that have tried to connect, or for anyone else that's curious, yeah, let's just spend like 5 minutes talking about the solar system, about the idea of space travel and setting up a station somewhere else, and why everyone is always talking about Mars. Well, first thing first, we all learn this very simple map of the solar system in school. Like, pretty much everyone learns in primary school, like the 9 planets. For about 8 years now, it's been officially 8. About 20 years now, since about 2006-ish. They decided dwarf planets were a thing, and things past anything past Neptune is not. But anyway, just to make sure that everyone has the same kind of understanding, same level of understanding, so no one gets confused when I start mentioning things. Our solar system, we have one sun, which is actually called Sol, S-O-L. It's right in the middle. Everything else is going around it. Yep, we should all know this, yeah. Basically, the sun is at the middle of the solar system, and then we've got a series of planets. There's Mercury, then Venus, then Earth. We are the third rock from the sun. Then Mars, Jupiter, Saturn, Uranus, Neptune. They're the official ones. There were a couple others that got knocked off the list not that long ago. And I might as well mention them because they are out there. They are kind of relevant. This idea that, oh, not the idea, that the fact that everyone's always talking about building something on Mars, about the first colony being on Mars, or building a station or something, that it has to be Mars. No, the idea of Mars was just because it was the closest thing to us. Now, there is science that there used to be water on Mars and Venus. They're both within what we call the green zone, like that ideal area, far enough from the sun, but not too far from the sun, because if it's too hot or too cold, all life is going to get nuked every day. So we're in that ideal zone. Mars and Venus were too. So with those facts, we know that it's in the right place and they had water. There probably was life there. But a couple million years ago, the atmosphere's evaporated. They got toasty. No life there, no sign of water on the top. Now, the reason that people want to go check Mars for water is because not just does it have signs on top, but all of the signs. There is so much evidence that there used to be oceans covering it just like Earth. So, either that water evaporated when the atmosphere broke up, which is most likely, or, and I wouldn't say or, I'd say as well, some water absorbed in. There could still be water there, but it's under the crust. Now, like our own planet, we have a crust, and underneath we have a mantle. We have the big solid area under it. Not the core, not the big molten area, just the rock. But if we go to Mars and we're digging to the mantle to try to find this water that might be there, we're talking 20 kilometers under the ground. A mining operation that huge is ridiculous. Setting up a station at all is a huge, huge effort. It takes so much energy and resources. It's crazy. It's the closest place to us, though. If we want to go somewhere further, it's going to take more resources. But the big limiting thing is how far we can go, how long it takes, and if we can restock, like if there is water. Because as soon as there is a sustainable reserve of water, then we can use the water to make oxygen and hydrogen. We can basically keep breathing, and we can keep the rockets going. We can keep traveling if we need to. So yeah, all we need is water. And we know Mars used to have water. So it makes sense that maybe if we dig down far enough, we might still find water. Now, there's no real big indicators that there's a huge ocean anywhere near the surface. That water will be under the crust. And like I said, we're going to be digging 20 kilometers down, hoping to find water in sufficient amounts in cracks and fissures. It's a big, big gamble. If there's anything there at all, it's very hard to find. And that in itself, now, there's going to be problems whatever you're deciding to do. So, fair enough to not just end a conversation on that. But why Mars? It's the closest place that might have water. It's the only place in the solar system that we know. Well, it's not. In fact, it's nearly the only place in the solar system that doesn't have any water. That sounds crazy because it's like the opposite of what we're taught in school, but now, going back to our map of the solar system, we got the Sun, Mercury, Venus, Earth, Mars. Earth is the only one of the inner planets that hasn't dried out because of our thick atmosphere. We go past Mars, we've actually got Ceres, which is not on that map that we used to use. It's a dwarf planet, a little planetoid, not a big planet, so it wasn't visible by the naked eye, which is why it wasn't included in a lot of the earlier charts. It wasn't until the last century that Ceres was kind of, well, discovered, if you want to use that word. It was found and added to charts, but people didn't bother using it in school charts because you can't see it through a naked eye or like a small normal telescope. It's a planetoid. It's a small, well, the term that we use now is dwarf planet. So yes, Ceres, a planet that most people probably haven't heard of. Again, dwarf planet. So the next planet on our list after Mars is Jupiter. Steve, you said water's everywhere. Jupiter, doesn't it? No, I guess. Okay. Jupiter, no oceans. Because Jupiter, Saturn, pretty much Uranus, huge gas giants. Now, they do have frozen rings circling them. Nearly all the big planets do. But I wasn't actually suggesting that we go using nets to scoop up icicles floating around these in the rings, which, again, is far, far more viable than digging 20 bloody kilometers after setting up a station on the surface, just so we can dig down far enough to build a station that could be sustainable. Still, okay, so forget Mars. Still, scooping up ice from the rings of Jupiter, it's a bit of a stretch. Because we know that Jupiter has a whole bunch of moons, and one of them, Europa, is basically an ocean planet. It's got a very thin crust, and it's pretty much water underneath. Like it's an ocean, and it's a moon, so a planetoid, not a planet, but it's an ocean. And it's the very next planet out. From Mars, the next planet is Jupiter, and it has a moon that is pretty much all ocean. The next planet, Saturn, has a moon. Well, most of these large planets have many moons, but and actually Europa, Jupiter has more than one with water, but Europa is the big one. It's an ocean. Plenty of water, right? Saturn also has a moon that has a thin crust. Enceladus, it has huge water reserves. We can see from the cracks and the formations on the surface that it has oceans underneath the surface. We know there's water there. Huge reservoirs of water. Oceans just under the surface. Not 20 kilometers down, maybe, possibly, we hope. Okay, so that's straight off of Mars. If you forget Mars, go to the next one. We had Jupiter has Europa. Saturn, Enceladus. The next planet, Uranus. Uranus has a moon called Ariel. And on the outside, looks pretty solid. But if you look at it, it's full of cracks where you can see the surface has become wet and then dried and wet and dried. It has spurs and spouts where there is hydrogen and vapor, like water vapor, coming out of jets. We've seen this from the satellite photos and videos. Like, it has almost constant streams of water vapor coming out of it. To be doing that now, it must still have water in it. We can see from the formations on the outside, it has water. We can see water coming out of it. It has water. Neptune also. Neptune was called this because when people first saw through telescopes, they thought it was an ocean planet. It turns out to be a big gaseous giant. You can't really go swimming there, but one of its moons, called Triton. That's right, Triton, one of the moons of Neptune. It also has subterranean oceans. 4 out of 4. Every single planet past Mars has a moon with oceans on it. Why the hell is everyone talking about Mars? Because it's the closest one. Now, even past Neptune, and since about 2006, everything past Neptune kind of got reclassified. See, we've got this thing called the Kuiper belt. The Kuiper belt, which it's basically an asteroid belt. Just space junk everywhere. All different shapes and size asteroids made up of all different matter. And some of these are enormous. We are talking, well, stop saying planets, planetoids. And yes, I'm going to start using the term that has been the standards for the last 20 years, dwarf planets. Now, Ceres, like I mentioned before, it's between Mars and Jupiter. It's actually very close to us, but it's quite small compared to the other planets. It's a little smaller than our moon, so it's not a massive planet. It does orbit the sun, though, so that's why it was called a dwarf planet. Now, everything past Neptune, they were reclassified because there was a bit of difficulty clarifying these things. Like, something in space orbiting something else, it's a satellite, usually called a moon. If it's circling a sun, it's a planet. But then we found all these different sizes and shapes, some of them quite small, some of them weird shapes. They had to be reclassified. Now, our classification was that if it circled the sun, then it was. If it was inside the Kuiper belt. Inside the Kuiper belt is the solar system. Outside that field was not in our solar system, which is why one of these dwarf planets, Hume, it has a weird elliptical orbit where it's outside for some of the time, and then it comes in, and it comes in right up near Neptune and then goes back. So for some of the time, it's right inside the solar system, and for some of the time it's outside. And there was some debate whether that should be included as part of our solar system, because it's a huge heavenly body orbiting the sun that's within our solar system's range. That started a debate back in 2002, 2003, that people debated at, and until about the end of 2006, 2007, when they decided that all of the little planet-ish things past Neptune are to be referred to as trans-Neptunal orbits or trans-Neptune objects. I've read both, so whichever one is the official today, okay. But all of these things past Neptune, which includes Pluto, one which used to be on our charts for a very long time. It wasn't just recently discovered. It's the furthest away thing that was visible to early telescopes, and even though some old star maps seem to have them, which is weird because we couldn't see them until we had telescopes, but hey. Still, Pluto, that ninth planet, which when I was a child it was, but then like I said, in about 2006 it got reclassified. So Pluto and its moon Chiron, or I thought it was Chiron, it's spelled Charon, but yes, Chiron, a planet, a moon of Pluto, and Pluto is a dwarf planet that's frozen. It's like covered in ice. And I mean, let's be honest here, it's not all water vapor. Like any chemical freezes, you hit a low enough temperature, but Pluto's covered. It's covered in mostly water. So we've got Jupiter has a moon, Saturn has a moon, Uranus has a moon, Neptune has a moon, Pluto, whether you're calling it a planet or not anymore, it's a dwarf planet now. It itself is covered in ice, and it also has a moon which is always frozen. We're not sure how much water is on it, but it's covered in water. And what's UB313 called? Eris. Now, Eris is another dwarf planet which is very near the Kuiper belt. It's on the inside, not the outside, which is why Pluto and Eris, by the old standard of anything inside the Kuiper belt who circles the Earth, they would have been included as planets, but by our new system, it's another planet, another dwarf planet. It too has a moon. Well, most of them have more than one moon, but Dysnomia? Yeah, Dysnomia. I have to check the pronunciation. I can't remember how to say it. But Dysnomia is a moon of Eris, which is also covered in ice. I mean, we haven't had anything fly past close enough to take good photos of it, but it's incredibly shiny. If it's not a huge ball of ice, it's covered in ice. So basically every planet and planetoid between Mars and the Kuiper belt, every single one of them has at least a moon which has oceans or is covered in ice. There is water everywhere. So again, Mars is a stupid idea.